What we're going to do is we're going to solve three variable systems using elimination. So when we're solving this, what we're going to do is we're going to start with our z's. And so I'm going to combine my first two equations. Notice that I have a positive z and a positive z. So what I'm going to do is I'm going to subtract each of these. And when I do, I get 4x minus 3x, which is x. I get negative y minus y, which is negative 2y. Then I have z minus z, which cancels. And then I have negative 3. I'm going to do the same thing. I'm going to combine these two. I'm going to keep the negative with that middle equation. So negative 3x plus x would be negative 2x. Then the y's cancel, the z's cancel. And so what I get is negative 2. So this makes it really easy because I divide by a negative 2, and I get x is equal to 1. Now I'm going to take the 1 and I'm going to plug it into my top equation. So when I replace it, I have 1 minus 2y equals negative 3. I'm going to subtract the 1, and I get negative 2y equals negative 4, so y equals 2. Now I'm going to plug both of those, the y and the x, and I'm going to plug it in for the bottom equation right here. So this one right here. I'm going to take the 2, plug it in for the y, take the 1, plug it in for the x. So that gives me 1 plus 2 plus z equals 6. That would be 3 plus z equals 6. So z is equal to 3. So I have an ordered triple, not an ordered pair. It would be 1, 2, and 3. Now, looking at this next equation, I'm going to do the same thing. What I notice with this one is that I have opposites. So I have opposite z's here, and I have opposite z's there. So I'm going to do the same thing. I'm going to combine the first and the second equation, and then I'm going to combine the second and the third equation. Since they're already opposites, what I'm going to do is just add the two equations. So for the first one, what I get is 12x, and then I get plus y, and then the z's cancel, so that's equal to 35. Then I combine these two equations. When I add that, let's see, no, I'm going to actually combine the first and the third because that's a negative z and a z. So that's 7 and 3, which is 10x. And then 3y and y is 2y. And then the z's cancel, and I get 28. Now what I want to do is cancel the y's, so I need opposites. So I'm going to take this equation, I'm going to multiply it by negative 2, and that gives me negative 24x minus 2y equals negative 70. The y's cancel. I get negative 14x is equal to negative, let's see, that would be 42. So when I divide it, I get x is equal to 3. Now, once I get the 3, what I'm going to do is plug it into one of the equations. I like this second equation right here. So I'm going to take the 3 and plug it in. That gives me 10 times 3 is 30. So I have 30 plus 2y equals 28. I'm going to subtract the 30. And that gives me 2y is equal to negative 2. So y equals negative 1. So I'm going to pick one of those equations to plug all 3 in. Let's see. It looks like I'm going to go for this bottom equation right here. So I'm going to take the 3 and plug it in for the x. I'm going to take the negative 1 and plug it in for the y. So 3 times 3 gives me 9. Negative is a positive. And then that equals 14. So that would be 10 plus z equals 14. So Z equals 4. So my ordered triple is 3, -1, and 4. Now what we're going to do is we're going to look at a word problem. It says a family went to the movies and bought 2 child tickets, 2 adult tickets, 1 senior ticket for $39. So I'm going to go 2C plus 2A plus 1S equals 39. The next family bought 1 child's ticket, 1C, 1 adult ticket, 1A, and 2 senior tickets, 2S, for $30. Another family bought 5 child's tickets, 2 adult tickets, and then 1 senior ticket for $57. Now, I could decide any one of these that I want to cancel. I think what I'm going to do is I'm going to multiply the first and the third, and I'm going to subtract the top equation. So that way the S's cancel, and what I get is 3C, and then the A's also cancel, so that makes it really nice. So that means 3C equals, it would be 57 minus 39 would be 18. So that means C equals 6. So a child's ticket would be $6. Now what I have to do is, since I only have one variable, I have to combine 2 other ones. So I'm going to combine let's do the first and the second. So what I'm going to do is, I already have a child's ticket, so I'm going to combine that top one by -2. And when I do that, what I get is -4C minus 4A minus 2S equals -78. And then I'm going to combine that with this bottom equation. So that would be 1C and then 1A, and then I have 2S. So when I combine those, I notice that the S's cancel. I get -3C minus 3A equals -48. I know that C is $6, so when I plug it in, I get -18 minus 3A equals -48. I add the 18 and I get -3A equals -30. So A equals 10. Now I just have to pick one of the equations, and I really like that second equation. It has very simple numbers. So I'm going to take the 6, plug it in for the C. I'm going to take the 10, plug it in for the A. So that gives me 6 plus 10 plus 2S equals 30. So that would be 16 plus 2S equals 30, which would be 2S equals 14, and so S equals 7. That means adult tickets would cost a total of $10. Child's tickets would cost a total of $6, and senior tickets would cost a total of $7.